Hello everyone, welcome back to my YouTube channel DataSpeaks. In this video, we are going to cover the last major built-in data structure in Python, sets. We have already looked at lists, tuples, and dictionaries. Now it is time to explore sets, which are specifically useful when you want to work with unique, unordered collection of data. Sets are widely used in data science tasks like removing duplicates, handling categories, or performing set operations like unique or intersections. So let's straight dive into the code examples and let's see how we can use sets widely while programming in Python for data science and machine learning projects. Let's begin with our very first set called fruits, and there I would like to assign few fruits. Let me add some more values here. Oranges. So I have apples, banana, grapes, oranges, mandarin, apples, oranges. If I run this line of code, and if I would like to print fruits, look at this. Surprisingly, we have lesser elements in the fruits variable comparing to what we have initially assigned. In the beginning, we had 7 individual elements within the fruits set. Now we have only 5. The reason behind this is because we have apples duplicates here in the original assignment. We have oranges duplicate here in the original assignment, and by the nature itself it removes duplicates, so it will keep the duplicates away. It will only keep the unique elements within the sets. So when we look at this, what are the couple of characteristics of a sets? A sets is wrapped up with the curly braces, opening curly braces and closing curly braces, similar to dictionary. However, dictionary is different because it has a key value pairs which sets doesn't have. Another unique characteristics of sets is it removes the duplicates. It removes duplicates when it actually executed and the values stored. If you print the fruits again, if you check the fruits again, you will not see these oranges and apples repeated again. They are removed and retained only the unique set of elements. That is one of the most important characteristics that we need to understand about the sets. Unlike any other data structures, you cannot store different data structures within sets. In the list, you could have stored another sets, list, or dictionary, but in the sets, you cannot do that. If I would try to put cities here and initialize sets, I would put New York, Boston, Boston, and I would like to put here another set saying San Francisco and Nashville. Let's see what happens here. It will throw an error. It says unhashable type set. Since you have the another set of set, it will not work in this way. Or if you like to create a list inside the sets, this will also give you error. So it cannot store multiple data structures within the sets. It has to be individual unique elements or individual elements, which again will remove duplicates and only will keep the unique values from the sets. This is how we can understand the major characteristics of sets. We can initialize empty sets by saying set1 equals open close parentheses, and you will call set function in the beginning. So this is how you can initialize set, but you cannot initialize sets like this. Sometimes it might be confusing that sets are wrapped up within the curly braces, so you may think I can initialize the empty sets with curly braces, but that's not the case. You have to call set with open close parentheses, and that's gonna be the empty set. If you check the type of set1, you will see set, but if you check the type of set2, you will say dictionary. So now this way you are initializing the empty dictionary, not the empty set. This way you are initializing the empty set. Let's review the properties of sets once again. They are unordered, there is no fixed index position, similar to how we used to call for lists and tuples. And these store unique values. Sets store unique values, duplicates will be automatically removed. So the first unique value will be kept, and then the values after that will be removed. And they are mutable. You can always add or remove items from the sets, and they are of heterogeneous on the nature. That means it can store mixed data type or different data type. They don't have to be of the same data type. Let's take an example of a set, which is called mixed set here. I have a value which is integer, floating point number, string, boolean, and a set with the number of the values, which is tuple. Basically, it is immutable, that is allowed in the set. So if you want to insert a value, then it has to be immutable. In that case, it cannot take the list. And data science again, here this is string, and this is the integer again, the floating point number, boolean, and the string. Let's run this and let's print mixed set. If you look at this, we are successfully able to define a set, and let's confirm with by checking the type of mixed set, which is set here. Now you can, since it is the unordered collection of elements, we cannot access the value by the index position. However, we can go through or access the element using the loop. For example, the for loop. I have created entire another video on for loop. Please do not forget to check that in my YouTube channel. Now let's access the elements of mixed set. How I would like to do that is for I in mixed set print I. If I would do that, I will get each elements of those in each individual line. That means I have extracted the elements of the set at each element level. Let's check a few common set methods. So there are a few things that we can do on the sets. Let's begin with checking, first of all, our mixed set that we had just recently created. And in that, I want to add a few things. So let's check the first add method. So in the mixed set, what we can do is we can add some value there. So we want to add United States, just for an example. And if I want to print the mixed set after that, I can see that the United States have been added to the set. However, you can see that the sequence is not the same as it was earlier, right? So we have the true at the last value of the set. However, true is now the second value of the mixed set. Why that happened? Because it is unordered. So this is not ordered. The values may appear in any sequence than what you have earlier defined. Now another method I want to introduce here is updating the set with multiple values at once. For example, I want to say mixed set dot update, and I want to introduce a few values here. Let's say New York and Chicago. If we run that and if we print the mixed set again, you've seen that we have the additional values added at the individual element level. It's not something it has been added as a single tuple, but it has been added as the individual value. You can do the same thing in the different data structure format. I want to say update, and I want to add some fruit names here on that. So banana, and I want to add apple, I want to add berries, right? Berries, if I run that, it's also successfully added some values. If you print the values of the set that we have added, we can see that banana has been added already, berries has been added already, and the apple has been added already. They are not in the sequence that we have added. They were added randomly in any position, because as we know that again, this is unordered set of elements that is stored within the set, and they are unique values. The duplicates will not be reflected even if you add in sets. Now, how about removing the values or elements from the set? If we want to remove, let's do the regular way, how we have been doing before, dot remove. And as we know that we do not work in the index level in the sets, we have to go at the value level. If I want to remove apple from the list, let's see what happens here. We were able to successfully remove apple from the mixed set. If I would run the mixed set again, if I would like to print the mixed set here, I do not have apple anymore anywhere within the set. Now, if I would also like to remove one more value in a different way, I want to do mixed set dot discard. If I want to pass Python here and run that, we were also successfully able to discard Python, print mixed set now. If you run that, we have no more Python in our set. So this is the technique. You can remove a couple of techniques. You can discard or remove the elements from the sets. You can remove values from one more way. Earlier, we learned the pop function within the list and sets, within the list and tuples. So let's use pop here. If I would like to say mixed set dot pop and just open close parentheses, then print the mixed set here. Let's see what happens here. We have removed the one of the element. Again, this is because of the unordered structures of the set. We do not see the last element being removed because earlier we had the data signs to be the last element. However, data signs is still there. Random element have been removed, and now you can see that false is not there anymore. Although the false was the first element in the set, however, it was not the first element by the index itself. Is randomly showed up as a first element. That being said, the false was removed as a random element using pop function, not necessarily being as the first element or the last or any specific index position. These are few ways of updating the sets. Also, you can clear entire set using the clear function. So if you call the clear method here, and if you run that and print mixed set, you don't have anything, any value in that. You just get the empty set here that has been called as set open close parentheses, and you have no values in the mixed set. Let's look at the last but maybe the most important operations in set, which is called set operations. Sets are mathematically inspired. They allow us to perform union, intersection, difference, and symmetric difference. Let's take a couple of examples of the set and we can test a couple of those operations. I'm defining a set A and set B here. I will run that, and now if I would like to union the values of the set, I can call the pipe operator between A and B. So A pipe operator B. If I would like to print that A pipe B, then look at this here. So A had 1, 2, 3, 4, and B had 3, 4, 5, 6. Then I have the new set with 1, 2, 3, 4, 5, 6. As we know that sets remove duplicates. In the beginning when the union happened, then we had 1, 2, 3, 4 and 3, 4, 5, 6. But at the final result of set, the duplicates have been removed and we have now 1, 2, 3, 4, 5, 6. Next I want to test is the intersection. Intersection is what are the common between A and B. A and B, and simply it will give me the result. So if you check the type still of A and B, then you will see that it's a set. So unique elements that are common between A and B. 3, 4 here, 3, 4 here. These are the common. So it will return common values between A and B. Next one we would like to test is the difference. Difference would have two different options. Option 1 is the values that are in A but not in B, and the values that are in B but not in A. First one, to accomplish this one, we can do A minus B. Let's give variable name diff A equals A minus B, and let's print diff A, and the next one B minus A. Let's call this as a diff B equals B minus A, and let's print diff B. And we have both of the results here. So diff A gave us 1 and 2, the unique values. So if you look at this set A, we have 1, 2, 3, 4, and set B has 3, 4, 5, 6. What are the values that are in A but not in B? So these are 1 and 2. And that's what we have received here as a return of diff A minus B. That means the values that exist in A but do not exist in B. Other way around, when we look at the result of diff B, we have 5 and 6. The values that exist in B but not in A. Next, I want to show you is the symmetric difference between A and B. So what exactly symmetric difference we are referring here? Symmetric difference here in set shows that what are the unique values in A and what are the unique values in B. We want to get the values that are unique only in A and unique only in B. We are removing the common values between both the sets. I want to say symmetric difference equals A caret B. If I print symdiff, look at this here, 1 and 2 and 5, 6. Let's print A, let's print B. So in A, we had 1, 2, 3, 4. In B, we had 3, 4, 5, 6. If you look at closely, 3 and 4 are the common between A and B. Now, in this symmetric difference calculation, we have received 1, 2, 5, 6 unique values that exist only in A and unique value that exist only in B, not the common one. So these are very useful and used operation in Python for many projects. So when you work in complex mathematical operations, checking the data, unique values, and keeping only a unique set of elements of the data sets in larger volume data, these operations are widely used and really important to understand from the perspective of data science and machine learning project and data analytics activity. Another operation we can do within the sets is membership testing. We had recently defined set A and set B. Now I want to check if value 3 exists in the set A or not. Imagining the set A is pretty large at this point, maybe from 1 to thousands or hundreds of thousands. And I want to check if any specific value exists in A or not. Simply what I can do is I can say print 1 in A, and that is true. I can say print 6 in B, that is true as well. Print 9 in A, that is false because A doesn't contain value 9. So this is really useful when you want to find out if a data set has the value or doesn't have a value. As we know that sets are mutable, we can update the values. However, we can make the sets to be frozen or immutable. The function called Frozenset, and we can pass the set that value we want to store within Frozenset is gonna be something that you cannot change after it is assigned. I want to put 1, 2, 3, 4, 5, 6. Let's call fs equals the Frozenset. If I would like to perform some actions which we have already performed, let's say remove, and I want to remove 3 from here. Let's run it. So Frozenset has no attribute remove. That means the set with the Frozenset becomes immutable. Then the values cannot be changed. This is particularly helpful when you want to store unique values and you do not want somebody to change it, and you want to ensure that this has a unique elements which set is qualified for, and also you want to ensure that nobody changes after it is assigned. Then the frozen sets are really helpful. This is all in the series of Python basics for data science, specifically in data structures. We have covered list, tuples, dictionaries, and now sets. In the next videos, we will continue using other part of Python basics, including for loops, conditionals, etc. Please do not forget to check those videos, which will be really helpful for you to understand and learn Python basics for data science. And slowly in this video series, we will also continue advancing on Python coding, which will be helpful for you to do the coding for your data science, machine learning, and AI projects. With that note, thank you everyone for watching this video and the video series on data structures. I'll see you soon in the next video.